well, welcome everyone to the Pi game computer vision little demonstration here for DurJam to hopefully teach you something that might be a bit scary in an easy way, just a little demonstration of what you can do. So I just want to quickly introduce myself. My name is Toby. Very nice to meet you. And I also run this little game development channel. The only reason I'm showing you this is because this is full of these stupid little projects that I've done very similar to this, and they all help me get a job and employment in the future, and also they're just really fun to do, and I would highly recommend it just for your own journey. So, but it also just shows that what we're doing today might actually be of benefit, so as well as being fun. So hopefully you just enjoy it. So what are we going to look at today? Well, there's two different ways of including computer vision in your game, at least that I've come across, and I think that are fun. So the first one is creating just a way of controlling already existing games, but just with your face or your hands or whatever. And an easy example of that I came up with, which I think is really fun, is this little mouth controller. So let's run this. And you can see it's tracking my mouth, it's getting my two lips here. And as I open, you'll see it lags, and that's because it's clicking my mouse. So yeah, perfect. And by doing that, we now have essentially a controller that instead of touching the screen, I can do anything I want. So what can we actually do with this? Well, I just launched Cookie Clicker there with my mouth. Hopefully I don't mess anything else up. But the fun part of this is obviously it's completely ridiculous, but we can eat cookies with our mouth, which is stupid, but you're going to learn some interesting computer vision tips here, especially Python, because all of you here, if anyone is at university, then we do Python here at least, and you'll get some good skills. Great, okay, so year 2, whatever, of any university, and because it's a university level thing, I think a lot of people just maybe get intimidated by it, because you think it's a lot more complicated. And obviously it can be, but it doesn't need to be. We can also even afford a grandma, which is lovely. Home, 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 home. Okay, so moving on. Okay, so the next thing, which you might be interested in recreating, is that the Switch 2, perfect timing, just came out before this, and they gave me a lot of inspiration. And being inspired by stuff like this is a great idea for anything you want to make. But you'll see at some point in the trailer, they bring in the camera, and they put... Why did it pause? Oh, it paused because I opened my mouth. So you can see it working already. But you can see they bring in people's faces and they place it in the game, and you can kind of interact with that. I'll let it play for a little bit.
Please look forward to games which use your camera feed like this.
Oh, wow.
Okay.
No, wait. Go left.
I'll let you fix
A little more this way.
Okay, that's probably enough. But you can see they're very happy with it. So am I. This sounds like a very fun idea. Okay, and this is kind of the second way of including computer vision in your games, if you want to, which is actually just building the entire game around it. And the easiest way to do computer vision is with Python. And luckily, you can make games with Python as well using Pygame, which is also taught here as part of the game development course. So this will be hopefully a great introduction to all of that. But even if you're using a game engine like Unity or something, we will see kind of equivalents to that, and how it's just more for ideas and just fun. But you can definitely still do all of this in that as well. It's just a bit more complicated. And the recreation version that I came up with for this is a little game of Pong. So you can see this is all built using Python and Pygame, and we'll go through the code and how you can look at it in a minute. But we just have a simple game of Pong, nothing too complicated. And let's just lose. And you can see, okay, the points go up, and it gets shot to the next person. So lovely. But how do we introduce the camera? Well, all we have to do is just increase the number of faces, and it's going to put that face using the computer vision that we just had before. But this time, it's just going to track my face. You can see I'm moving around, but it's still staying on the paddle, which is great. So we've got the face tracking there. And it moves around with the paddle, just as it does in the Mario Party example from the Switch 2 that we saw earlier. And you can see that everything moves around just perfectly with Pong following your face. And this is obviously enhanced even more with multiplayer. You can see that we can also, lovely cameraman here, thank you for organizing, this is beautiful. No, so we can have two faces now. And I think you're going to be the first player because you're on the left. Oh no, Ooh. Perfect, there we go.
Yeah.
So,
and as we move our faces around, they're still tracked. Like, even if I go almost out of frame.
Exactly, well it does break a little bit, but it gets rid of your face. Yeah. And we can now play Pong against each other using fully tracked faces. It doesn't, get us mixed up, and it knows which one of us is which. So it tracks each individual person, detects our faces. And overall, I think already this is just kind of a more fun way because you can actually see each other. So there we go. Let's see how all of this works. Okay, so here is the beginner template, I suppose. This is kind of the master template of any time you want to do anything computer vision with Python. So much so that we'll just give you this file. Hopefully you can find it somewhere linked around this video. I'm sure that'll be fine. And just basically copy and paste this in every single project you ever do, and then you can work on it from there. That's how I start all of mine, and it's just a lot easier to do that. So CV2, which stands for Computer Vision 2, because Computer Vision 1 wasn't good enough for some reason. And this is the module in Python that lets us do all of our computer vision amazing stuff. It's the module you use in university and courses, and it's most popular, and it's just fantastic. And very simply, we can just start by getting a capture object, which is the camera. So you put in a 0 here to try and get different cameras, because you might have, say, we have one camera in my laptop, which is 0, it's kind of like the first camera, and then the other camera might be this one recording properly, and then maybe you have another USB camera or something like that, but 0 just gets the first camera, so it's nice and easy for me. And then we just have, while the camera is opened, we'll try and read frames from it. If we fail reading a frame, it didn't work, then we'll just break, which closes this while loop, comes down here and kind of destroys everything. So this releases the camera so it can be used by something else and closes the window. And okay, so once we've done that, we get the frame read successfully and we just show it. And because we're making a mouth controller, we're just going to call the window name mouth controller. We also just have a little shortcut, because you will see when we run this that the window, for some reason with computer vision, doesn't have the little red X or the equivalent you'll have in Windows. So you need some other way of closing the window. We can just press Q to do that. But you can see it showed our face, and that's absolutely perfect. That's all we wanted. So obviously, the next step is being able to track your face, detect your face, and then we need to figure out some way to go from the face tracking to detecting your mouth being open. But we'll start with just the face tracking. So we can just check out this file here. And we've imported MediaPipe now. And if you want to know what MediaPipe is, or you're a bit worried about it, don't, because I don't really either. I just know that it's enough to detect faces. And you can see we can import it as MP, kind of the same way you would with NumPy, import that as NP, just conventional. And it gives us this face mesh detector. And we can see all these parameters here. The maximum number of faces is 1, because let's say Oscar Lovely walked behind me again while I'm trying to do this one. Well, I only want to track the one person, so we just want to limit it at 1. We refine the landmarks. This makes them higher resolution. So in some cases, you don't actually need to care so precisely where the different landmarks of your face are. What are the landmarks? They're just the things on your face that the MediaPipe is looking for. So for example, your nose, your cheeks, eyes, mouth, and obviously in a lot more detail than that, like individual points along your lips, stuff like that. But we need them in more detail because we want to be tracking the specific points around our lips so we can tell where the mouth is open or not. And it just makes it a little bit more accurate. We also have this confidence here with minimum detection and minimum tracking confidence. And you can see here, it actually tells us what they are if we just hover over it, which is nice. But this is a confidence level from 0 to 1 of just how much we need to think it's a face before we'll consider it a face. Because if something was sat next to me, which is maybe a face, maybe not, a bit, sometimes like some of those illusions, I could probably get one up, put it on the screen right now. It's like something looks like a face, or like, I don't know, it's like Jesus in like a cup of tea or something. You think it's a face, but it's not. And even you might have a level of confidence in yourself, how much you think it is really a face. And it's the same thing with an AI model. We just need to tell it, if you're more than 50% confident, so you think it's probably a face, then we'll accept it. And this can be tuned for however you want, but for me and my camera, my background, my setup, that's what worked for me. Okay, so you'll see we also have this MP drawing, which is the same thing from MediaPipe. You can see we have MP solutions, we have MP solutions again. This time it's our drawing solution, and it will just allow us to draw these points on the face, because that's kind of an additional thing. You don't actually need to do that, because you don't need to be able to see the points, but it's good to be able to see them as an additional step, just to make sure that everything's going correctly. And then you can always turn it off again if you don't want to. Then this is all the same. We just process having a camera open, and you can see why this is just kind of boilerplate. And you kind of just forget about this after a while, or this part. You kind of forget about it after a while because it's just kind of there. But if you move on, we can see we now have the frame that we got, and we're doing something with it now. We're going to chuck it into the face detector, and we're going to process the current frame from the camera, which is going to give us some results, nothing too complicated. And this results is really powerful because this just has our face in it. That's really all we have to do. It is literally the entire face detection is this one line, which is quite impressive. Then we're just going to check that we actually detected a face, because if my face isn't actually there, then if we try and access the face, it's going to break because there isn't one. So we just need to check there is one. And I'm also just going to be extra safe. We don't really need to do this just to guarantee there's only one face. And if there's not, then we'll just move on. Okay. Then we're going to get the face landmarks. So these are the points over the face. And that is simply just from the multi-face landmarks and then the first index. Now, for some reason, this is just a gripe I have with MediaPipe, you have to access it as if there's multiple faces and get the first one, instead of just getting the first face. But it's fine, whatever. So we have the first face, the landmarks here. We can draw these now using our drawing utils onto the frame. What do we want to draw? The face landmarks that we just got from the face. And then all of this is kind of just different methods of drawing the face, and I think the best way around that is to just show you. Okay, so right now you can see this is just drawing the landmarks on our face, and it's doing it in blue, and it's kind of connecting all these points together. And you can see, you know, some of them are more in detail around the nose, the mouth, the eyes, stuff like that. And the method of drawing is this face mesh tessellation. Well, say that's hard to say. Anyway, face mesh tessellation, which is the way of connecting things that we saw as almost a graph of all these different points connected together. But you can see that you can pick loads of these. You can pick whatever you want. Let's just go for this one, contours. So this should be different, you know, height and gradient lines around the face. I've not actually done this before, but let's see if it works. And yeah, so it's just preference on what kind of method you want. Okay, so I can see along my eyelids here, you can see these lines where it's detecting that these are the same, you know, the same height, same depth. It doesn't really work anywhere else, which is a shame, so maybe we can try another one. But it's always fun to just mess around with this just to see what you want. But again, it doesn't actually impact detecting our face, because that's just these landmarks. This is just, you know, drawing it on for fun. Maybe we can do the lips, sure, because we actually want to detect the lips, so that might be even better. Oh yeah, so it draws all the points always, but it's just connecting our lips this time because they weren't connected last time. So play around with it, do whatever you want. Let's just keep it like this for now. And then this is how we're drawing. The landmark drawing specs are the individual points that were on the face, and the connections is the connections between the points on the face. I just make them both. My IDE thinks I'm making them red. They're actually blue because OpenCV does this weird thing where frames are inputted in the BGR color space and not the RGB color space that you're used to. So I probably should write that down. Let me see. BGR, not RGB. So what is that? All of them are just kind of shifted around. So this is actually blue, which is why they're blue, all in blue, and then no green and no red. And you can fix this, but I couldn't be bothered. Maybe leave it open to you to have a go at that. Okay. We can see here, we can draw the landmarks. So let's bring this back. And what does drawing the landmark IDs do? So let's just see this quickly. And now you can see that we have actual numbers. Hopefully you can see these in white now, above each one of these points. So the one up here on the top of my forehead is 0.10, and this one's 0.338. I have no idea how the numbering system works, but it's going to be important. And most importantly is because we need the ones around our lip. So you can see there's 37 here, 267, a 0, and we're going to need those points of interest. So I'm just drawing them here so we can check that they are the numbers that we want. And then obviously this is the rest. So let's move on to just the next bit now. We're actually going to use these points. And luckily for you, I went ahead and I looked at this map I took a picture, I looked at the points that were along the lips, and I just wrote down these points here. And these are pairs of points. So as you go along the lip, you have the top lip point is 191, the bottom lip point is 95, and then on this side of the lip, it's 415 and 324. I also found this amazing Stack Overflow article, which is always useful to just look stuff up like this as you're coding. Don't ever feel ashamed about it. You can find this great little picture here, which if you zoom in a lot, you can see it actually numbers all the points. And you can see that we need these points along the lip, which are hopefully what I just read out, 415, 325, 191, 95, which is these points along here. So those are the points we want. And let's just run this just to see what the difference is. Okay, so now, instead of drawing the entire thing, because we don't need to do that anymore, we only care about the lips. So we're just drawing the points along the lips. And in blue, we're drawing the connections between them. Okay, so you can see that now we have this information. How would you really go about seeing if the mouth is open? Now, this is kind of an easy question in this case, but breaking it down into these simple steps is very important. And I think, obviously, you can see my mouth is closed. Yeah, the lines are really small. I have basically no height whatsoever. If my mouth is open, the lines are really long. So the idea is going to be, we can use the length of the lines between each of these points, and then once it's longer than 5, whatever, I have no idea, but once it's longer than something, we're going to say the mouth is open. If it's less than something, we're going to say the mouth is closed. So for the landmarks now, we are going to look at, so we have all of our face landmarks that we want. This is the same as last time from before. But instead of looking at all the face landmarks and drawing them with the util, we're going to do it all ourselves. Now, we have the IDs of the top and bottom lips that was defined above from the image, and we're going to put them together. So this is going to pair these IDs. So the first one is going to go with the first one, the second one is going to go with the second one. So this is 80, 88, 81, 191. In fact, I can probably just show you this quickly. Okay, yeah, so you can see this, the zip object, kind of, if you imagine, this is, we need a visual demonstration here, but you have a zip, there's the two bits of those annoying jaggy bits that go together. And as you pull the zip across, it kind of closes them. If it's like this, then as the zip comes across, it's going to close them. So if you imagine here on this side, we're going to pull the zipper along, and 91 and 95, they get put together. And you can see they go together there. 80 and 88, they get put together, and all the way into the end. And this is great because these are the numbers of the ones that are directly on top of each other on the lip. So we now have the top lip ID and the bottom lip ID in these pairs. And from the landmarks, using their ID, we can get the actual position of those landmarks. Now, those landmarks in MediaPipe's detection, they don't care about the size of the actual frame you're looking at. It's just a simple 0 to 1 scale on the X and Y instead of 0 to 720 by 1080 or whatever it is. In actual pixel coordinates, it just uses, I'm not sure what the coordinate system would be, but it's just 0 to 1 as a how far along and how high are you. So we can convert that back into actual pixel coordinates for both the top and the bottom lip, just by multiplying by the width and making sure that it's an integer. And then we're going to use cv2.line to just draw a line between these lips, which is very simple, just everyone knows hopefully. Define a line by just 2 points. What are those 2 points? The top lip and the bottom lip. We're going to draw it again on the frame, just the frame that we got from the camera, and we give it a color and a thickness. Then we also just want to draw the top lip and the bottom lip, and we do that with just drawing circles in the position of each of those, and also we put the text of the ID, we put the name of the ID, just its number, that's the text that we actually want to write, and its position is just slightly above the actual ID, so it's not, or the actual circle, because otherwise they'd be overlapping each other. And yes, you're seeing this right, minusing 5 makes something go above, because in our OpenCV, the 0, 0 is in the top left. And as you go down, Y increases, which is slightly annoying, but it's actually quite common. So it's good to be able to work in different coordinate spaces like this and just get used to it. But, worst case scenario, you do this to begin with, you notice it's in the wrong place, and you do that. And then you're right, and it fixes it, and who cares, because no one's ever going to know you did that. So it's all good. Okay, so that's everything here, and let's just show it again quickly. Okay, and now we just have the lips. So what we need to do now is use this lips to know if the mouth is open. And that is conveniently enough over here. So all of this stuff is the same, other than we are now keeping track of each X position that we go through as we go along this line, and each Y position, and the length of each line. You can do this kind of in a lot of ways, but this is just the simplest way just to get it done, because Python code's more just quick and dirty just to get something done, and then we can come back to optimizing it later. But for something like this, you really don't need to worry about it. So you can see that now we're just going to add, every time we come across one of these landmarks, we're also going to save just all the X's and all the Y's in their own little list, and the lengths, which is the difference between the top and the bottom lip. And the reason this is absolute sign here is that because of the fact that the top lip is actually a lower Y value, because Y increases as you go down, it was just kind of weird to think about, because technically it should be bottom minus top, but it just looks nicer. And if you don't want to think about it, then just absolute the whole thing. And then even if you've done it the wrong way around, it's going to go positive anyway. and you'll get the difference between these, which is the length of the line. Okay, so the next thing we do actually then is we can get the center of the mouth. So we can put how wide our mouth is open, and we need to put it somewhere, and just putting it in the center of the mouth is nice because we're going to be looking at the camera anyway. And we can easily get the center of x and y of the mouth by just getting the average, so the sum divided by how many there are, of the x coordinate, of the y coordinate. If you average along all things along, it's going to go in the middle. Average along this, it's going to be the middle. If we do that on both axes, it's going to give us the middle of the mouth. And we just draw a circle there in exactly the same way as we did before. Then we need to calculate the actual amount that our mouth is open. And I'm going to do this by, again, just averaging how long the lines are between the points of the lip. And I'm going to just randomly define this 40 here for kind of the threshold of, is the mouth open? So if the length of the lines is greater than 40, then the mouth is open, and if it's not, then it's closed. And we just change the color of the text so we can visually just see that that change is happening. And then we just put the text the same way we did before again. So if we just run this, you can see we still have the lip detection with the lines now, but we also have this number in the middle of my mouth. If it's closed, okay, you can see it's 0. And if it's open, it goes to about 50, 55. To me, when I properly open my mouth, and you might need to adjust this for you specifically, but I think this kind of works with a few different people. But about 40, to me, just kind of felt like the right number for how wide your mouth is. But the beauty is you can just change it however you like. So that's pretty much it now. The final thing we have to do is just actually click the mouse, and then we can do stuff with it. Okay, so at the top of the code here, we've added a new variable, just was the mouth open? And this is simply just us, a little flag telling us, was the mouth open on the previous frame? Because that's all we know so far. So let's say my mouth was open, this is going to be set to true, and then the next frame we need to detect the face again, and we can set this and see what happens. So we come down back again. Okay, and you can see that we can say if the mouth is open this frame, which we just detected the same way last time because that was how we determined what color the text was. So we know that's working, which is good. If the mouth wasn't open the last frame, then we know that on this frame we went from closed to open, which means we've just opened our mouth. Which means we can click mouth open, or we can say mouth is open, and we can use this new and final module, PyAutoGUI, to click the screen. The same way as if you were to take your mouse and physically click. This will simulate that click, just in code instead. And then we just set was mouth open on this frame to true. We're at the end of this frame, so at the next frame, we then know what happened last time, so we don't kind of spam this and click every single frame the mouth is open, because for cookie clicker, for example, that would make you a bit too strong. You need to be able to eat each cookie instead of just holding your mouth open and spam click 1,000 times. Almost like an auto clicker at that point. There's no fun left in the game. And we can do the exact same thing here. If the mouth isn't open this frame, but it was open last frame, then it's closed. And we just set was open this frame to false, because this frame, it's not open, and that's why it's just been closed. Okay, and then the camera feed, we just show again the exact same way. And with just that tiny addition, you can see that now, okay, you can't see. If I move my mouse off the screen, and I'll open my mouth, and it's going to hopefully click through to the code, and this camera feed's going to go away. Perfect. And you can see it's printed, mouth open, mouth closed, mouth open, mouth closed. And the reason I made it 40 is personally just so I can talk a bit without it activating, because otherwise this would be a complete nightmare. So for you, maybe you might drag it down to 20 or something, that's fine. But perfect, you can see, as I'm opening my mouth, I'm clicking around. And the brilliant thing about that is that this is now ready to go. You can see that if we open Cookie Clicker, that this is all you need to do. Yeah, perfect, okay. So we're now eating cookies. But that's not it. Because this is a general controller that's just essentially emulating your mouse and keyboard or a physical gamepad or anything like that, this can be used to play anything with some slightly different rules for each game. And one example would be also Geometry Dash, which is a lot more complicated than Cookie Clicker, so it might need a few adjustments to make work properly. And why would you want to do any of this is an interesting question you could ask me, definitely. And I think bringing the fun into games is something Nintendo knows very well. And they had honestly, I find a bit of genius when they introduced this camera. Not that I've bought it because it's too expensive, but the idea of putting your face, you can actually see it in the game, and interacting, they've always innovated, with motion controls or whatever. They've got a mouse, this time on the Switch. It's always trying new input methods, because having that bit of novelty when someone plays your game and it's something they've never seen before, just makes it interesting. And having that piece of interest in your game, it's just really fun. And even just experimenting with it and do something stupid is worth it. So you can see, hopefully, I can click into, I'm not touching the screen. We can start, and let's see. Okay, it's quite difficult. No. Okay, so you can see a problem here is that at that part of Geometry Dash, I'm sure everyone knows this level at some point probably, but there's 3 little jumps in a row. So it's going to be completely impossible for me to actually open and close my mouth that quickly. So for Geometry Dash, kind of unlike Cookie Clicker, where we didn't want you to be able to spam click all the time, for Geometry Dash, I think I'm going to make the fair assumption that you do want to be able to. And it's simply just, if your mouth is open, you should jump, and if it's closed, you shouldn't. So we can adjust the code to do that. So we basically just want to disregard, pretty much, all of this was open stuff, because we don't care. And instead, we can just take this left click out of here. We can delete all of this, and we can just say, if the mouth is open, we're going to click. Now, I'm scared to do this, because as soon as I do, I better keep my mouth very closed, because otherwise I'm going to spam click, and it's going to be hard to close everything. So, let's give it a go. It's also probably worth noting, actually, this is why we added the escape key with Q, because no matter what goes wrong, and the mouth is out of control, because this is always a bad thing when you give a computer, or even maybe an AI in the future, access to your mouse and keyboard. Could be a terrible idea. So having a key to get out of everything, you just press Q and close it. Very neat. Okay, so hopefully this is a lot easier now, if I try. Okay, new best. You know what, that's good enough for me. But you can see the idea is solid, and this is just a fun way of playing some games. It's a bit silly, of course it is, but hopefully you learned something with that. And we can now move on to the slightly more complicated, but not too bad, Pygame version, where we actually integrate the computer vision into the game, and not just controlling the keyboard and stuff afterwards. Perfect. Okay, so this now is kind of the beefed up version of what we just had. Because what we just had, it was a simple script where all of the variables were just local to that one script, and no other scripts needed to care about it, because it was just clicking the mouse and that was it. It was a self-contained little program. Now, however, we want to be able to integrate this face camera, the computer vision stuff, with Pygame in this example, so we can actually make the game of Pong that we showed you earlier and link the camera to that, so it's part of the game itself. In order to do that, I've just defined here a face camera, kind of inspired by what Nintendo made, the face camera class, which has the same detectors and capture objects as before, but this time they're part of a class instead of just built into the file. And when we run this file, we're going to initiate the camera, and we're going to say we want to track one face. And you'll see this is very similar to what we had before, it's just a bit more built up now. So what happens in this init face? Well, we do basically the exact same stuff that we did in the previous script. We just make our face detector. I've upped the confidence here a little bit, just because with 2 people tracking at Pong, it kind of flickers a little bit, which isn't very nice, so we increase the confidence. We use the number of faces that we wanted to track just from that was passed to it. And then we open the capture object. And that's it, that's all we need to do in init. Then, whenever we want to get a frame and get a surface, we'll come back to later. But we just open a while loop here, so we're not controlling things as confidently, this is just simply a little test. We're going to get the frame from the camera in a very similar way to last time. If there's no frame, if there is a frame, if it's not none, then we're going to show the frame in the same way we did before. And we're also going to break out of the loop if we press Q. This is the same, just written a bit differently. Yeah, and then we're just going to be able to close the camera feed again with Q if we want to. So let's run this and just see what happens, see what the differences are. And you can see that there are no differences. It's exactly the same. It's still got the camera feed. But this time, we're actually processing it in a bit different of a way, which we'll show you in a second. So instead of drawing the face on my face. We're just drawing a little circle around my face because that kind of indicates the bit of my face that we want to take and crop out and put on the paddles of Pong. This is just a little visualization just to make sure that it's working. But this is still in OpenCV world. We still can't access this in Pygame. So how are we getting that red circle? Just still in computer vision world for now, and then we can move over to Pygame later. So we get the frame by simply checking if the camera, instead of looping while the camera is open this time, we're going to close the loop if the camera is not open. So it's very similar, but it's just an easier way of doing it because we're not controlling the loop ourselves anymore. We're going to have Pygame tell us to update the loop because we're being controlled instead of being the entire thing. We get the frame in the same way, and if we're not successful, we still kill the camera in the exact same way, so that's still hopefully okay. We also, in the exact same way, we still use the face detector to process the face, get the results. If we detect nothing, then we just return and say that we didn't get a frame, we return nothing. So this first return is the frame itself, the second return is where the faces are. And obviously, if there's no faces, then we don't want to return anything, we'll just do nothing. And here we are. So this time, we're going to go through every landmark of the face, and we do want to be able to detect multiple faces this time, so we're going to loop through all of the landmarks that we detect of people's faces. So this time we're going to go through each landmark, so all the landmarks this time, because we need kind of the average position of the entire face to get the center. And we're just going to get all the X's, all the Y's, bung them in this little list to just keep track of everything. And then kind of in the exact same way we did before, we can get the center of not just the lips this time, but the entire face. So that's where we want the center of the circle to start from. It's probably roughly the nose or something, but it's easier to just get the actual center instead of guessing. We also then need to get the height of the face, because most people's, I think this is fair, faces are taller than they are wide, and if we just use the width, you might cut off their chin and forehead. So if we do the height of the head, which is just the maximum Y point that we discover minus the minimum, will give us kind of how far apart the two landmarks are, how tall the face is. And then the radius of the circle we want to draw is just going to be some multiple of this. And now technically, it should be 0.5, right? Because this is top to the bottom, so that should be the diameter of the circle. Radius is half that. But the face mesh that we saw before, hopefully we can just edit it back on, it doesn't actually detect the literal top of the face. It kind of stops around the eyebrows. So you can pick literally any number here you want. But 7.75 gave me a nice circle that I kind of liked. And then all we need to do, if we're drawing, so this is just, sometimes you want to get the frame and just the information without having all this debug stuff drawn on top of the computer vision frame. So when we're doing the tester script like this, you can see we're passing in true here because we do want to draw that red circle. When we're in Pygame, however, we don't want to draw that red circle on the frame because we'll ruin it. We'll have a red circle in the way, and then that's going to interfere with the Pygame stuff we want to do, which isn't very good. But we're just going to draw that circle in the same way and save this information, because all the information Pygame needs, of all the landmarks, all the detection, doesn't care. All it needs is the center position of your face and the radius of your face, the circle around your face. But now with that knowledge, you can see that this is maybe hopefully less intimidating. We're just drawing a circle and getting that from our face. So no matter where we move our face or how far we come in or out, it's still going to have our entire face instead of just assuming the face is a fixed size. I think that's pretty cool. How do we actually put this into a Pygame project? And this is the important part, because you'll have access to this file, also hopefully linked somewhere, that you'll have easy access to. And you can just dump this face.py file anywhere in your Python project, in your directory, import it as you would anything else, and use this get surfaces method that you can see down here. Very mysterious at the moment. This get frame is still talking in frame world, which is computer vision frames. Surfaces is how Pygame handles things, where you can kind of imagine almost like a collage or sticky notes, something like that, where you have, okay, so you have, your surface, actually perfect, the entire whiteboard, let's assume that's just the window. And let's say I have a new surface, which is just, they're all surfaces. The whole big whiteboard, that's a surface. If I had, I have a piece of paper here. This is another surface. Let's say this is the face, and Pong is on the whiteboard somewhere. I can stick this surface on top of, I realize white on white is probably not brilliant, but I can stick one surface on top of the other wherever I want. But in order to do that, we do need whatever this surface, this face is. So we can convert from OpenCV frames to surfaces using that face information to kind of cut out the face. And we're going to just initialize, we have no faces to begin with, obviously it's an empty list. And we're going to get the frame from the camera this time without drawing. And if there's no frame, so the camera just didn't work, then we will just do nothing, return this empty list. And actually, if I just quickly demonstrate that, you can see if I cover my face, yeah, it goes away. It doesn't break, anything like that. But that's just because it didn't detect any faces, which is pretty good. Okay, so what do we actually need to do? So we have an entire frame, the entire camera's worth of data with, we can imagine that red circle being there, but it's not actually visually there. And we need to cut out just a circle around the face. Now, the first step for me, which I think is easiest, that for every face we find with the face info, and keep in mind that this face info is the center point of the face and the radius. That's just what we defined this to be earlier when we returned it from getFrame. What we need to do is draw a rectangle around the face. That's kind of the easiest thing you can do to begin with. Just take the entire frame, find the box that fits that face, fits that circle, and we'll just crop that part of the frame into a smaller subframe or a cropped frame or whatever you like. And we can do that really simply by defining the top left and the bottom right of that rectangle. How do we get the top left of that rectangle? Well, the first position will be the center minus the radius. That's the left part of the box. The right part of the box is the center plus the radius. If you imagine this box is going to have side length 2r or diameter. It's kind of just we can get a graphic hopefully of a box sitting inside a circle. So we have that circle, we need to make the box that fits it. Then for the y coordinate, it's exactly the same. We do one below the radius, or one radius below the center and one radius above the center. And we can just use simple indexing in NumPy to just crop this frame to be purely inside the indices of this box. So we're only going to take the part of this frame that's between these two y coordinates and between these two x coordinates, which is going to be the cropped frame around the face. So we're not done quite yet, unfortunately, because as we saw earlier with those weird colors being all wrong, that it uses BGR color space. And we still need RGB, because Pygame is a good game engine, and it uses the right color space, unlike OpenCV. So we do need to convert it now into the right color space so Pygame can understand it correctly. And we can do this with just converting the color from BGR to RGB. And we can start petition hopefully to just make that the default at some point. I'm not sure if it'll work, but we can give it a go. One slight annoyance as well, which we can try for fun, just removing this line and not doing it so you can see what happens, is that OpenCV also has the frame's dimensions go height, width, depth. Now height and width are kind of obvious, they're the size of the frame. Depth is the color space. So if it was a depth of 1, that would be black and white. If it's 3, you have your RGB channels for the depth of the image. But we need in Pygame it to be width, height, depth, which is, again, I think the more intuitive way of doing it. And the way we can do that is we can use NumPy transpose, which just switches around the axes. So you can see that if this was to be the exact same as it was before, we would just have 0, 1, 2, because that's just how they are to begin with. But you can see we want to switch around the width and the height, the width and the height. So we can switch around the indices to go width, height. But the depth stays the same, that's still in the same position. Okay, so the final thing we need to do, that we actually need to do, is convert from a frame, which is just essentially a NumPy array. So the final thing we need to do, make a Pygame surface from an array. Luckily, surf array, we can make a surface from an array. And that's all this does. The convert alpha here, we don't actually need for now, but essentially what that's going to do is that because all surfaces are rectangular, if you didn't have any alpha, which is transparency, then the kind of bits outside the circle would still just be completely black, because we only have the camera circle from the face is what we're going to keep, but the rest of it would still be black around there. So we need to make it transparent in order for that black surface, which is still inside the square, to disappear. So we don't actually want to have it, which is nice. Okay, so this we can understand. The last step now is this masking. which is a complicated concept, I think, to get and to understand. I don't really like it either. So let's just get rid of it, and you can see what it does without this. So this is the surfaces of the faces, the sticky notes that we're returning to Pygames that it can use. So instead of masking and getting the circle from inside the rectangle around the face, let's just keep the entire rectangle. And you should hopefully see now that the camera feed is the full rectangle that we cropped out. So that's exactly what we wanted and expected. So we took the full frame, we cropped it down to just be the little box around my face, and now we're showing it. But obviously this isn't what we wanted, because we still want the nice little circle like Nintendo has, and this also just looks better than having these hard edges. So the way we do that is with a mask. And you can kind of imagine a mask as just a way of defining, we want to keep everything inside this and get rid of everything outside of it. Or the opposite, we can get rid of everything inside this and remove everything outside it. And the mask shape that we want is a circle, which is quite lucky. We just want to put that red circle that we drew in computer vision earlier back in. So we make a new mask, which is again just another Pygame surface of the exact same size as this rectangle, so we can change pixels however we like. And it's obviously going to be transparent again as well, because the part we want to include is the circle, the part we don't is the background. And we're going to draw that circle onto the mask. So this mask, if we showed it now, would be a completely white circle on the screen with a black background around it, which is the box that it was in. We then apply this mask on top of the box of the face. And the special magic is, if we got rid of this special flag, so we'll just show it right now, and we play again, you can see that, okay, so we have the circle in the face. Oh, so you can see this is why if I don't move, it's fine. That's why I made it. Because for some reason it double detects one person, thinks it's two people. But we can ignore that for now. You'll always have these kind of artifacts in your games, but just a quick and dirty fun thing like this, it's okay. So you can see that I've got that white circle that I wanted to crop out of my face, but it's covering my face. It's just a white circle in the way. But if we put the special flag back in, instead of just putting the white circle on top of my face, it blends the special, okay, so it takes the frame that was there previously, and instead of overwriting it with this circle, it blends it with the circle. And the reason that that's so special is that it's multiply. And with multiply blending, it's going to take the pixel, so top left pixel, you're going to have what was there originally, and you're going to have what we're trying to put there now. Okay, so this is a bit of an abomination, but I just wanted to quickly come back here when I'm explaining what the mask looks like. So this right now is rendering the mask. And you can see it's a white circle inside this black background box. And obviously black pixels are 0, 0, 0 because there's nothing there. And the white pixels are maxed out 255, 255. And in the face here of our mask, we're rendering the mask. What we want to be rendering is the surface. So we'll put that back. We'll just undo actually. We'll make it transparent again and we'll render the right surface. So with special flags off, this is going to add the mask to the surface of the face, which we saw before, which was just a white circle over where my face was, which isn't what we want. It just replaces the pixels that it goes on top of. So if whatever the pixels was before, it doesn't matter. It just puts white there of the circle. But if we add the special flag of blend RGBA multiply, this, amazingly for us, will multiply the value of each pixel in each position, where all of those black, the black parts of the mask that we're wanting to apply, normally when you add them, it's just 0, so nothing changes. But when we multiply, that 0 will kill whatever was there before and make it 0 as well. So anything in the parts around that circle that we don't want to include get multiplied by 0 outside the mask, get rid of them. Anything inside the mask is just the whites areas, which was 255, so when we multiply it, we just get exactly the same color back again. So it's fantastic. Because we're essentially multiplying by 1 in color space world, because 255 is maxed out 1, black is 0. Okay, and then we just add that face to the surfaces that we're returning, and we return the surfaces. And the only thing left to do is to go into your Pygame project. So for me, That's Pong here and the Pong surface. And where I am drawing, you can see all this fancy stuff. We've got the background, the center line, the paddles, the scores, the ball. We have the faces. And if we want to include faces, we can call the draw faces method, which you can do. Sometimes you can play it without the faces, you can play whatever you want. All we need to do now is just grab the faces and say, okay, we want a left and a right face for Pong. And the reason this isn't any hard-coded is because this face camera can be used for anything. For Pong specifically though, we want a left face and a right face to go on the paddles. And if there's one surface that we found from the camera, then we're going to say that that's the left player. Just kind of tradition, I suppose. The player is normally on the left. If you were maybe playing against an AI, you'd only want one player, one person. Whereas if there's two, then we're going to get both of them. And then we're just going to draw the left and right surfaces. And because we're in surface world now, you don't need to think anything about Pygame, or you don't need to think anything about computer vision. Where these face surfaces came from doesn't matter. They're just Pygame surfaces at this point. So the way of drawing these on the screen is the exact same way that you would draw any rectangle, just a solid square or an image or anything like that. You literally just, you take the face that we wanted to do. We apply some rotation here. You can see it is when the paddle bounces, but you apply rotation and then you just split it to the surface the same way you would anything else. And that's how it works. And I think that is hopefully everything. I hope you've enjoyed very much. I hope you've learned something, and hopefully more importantly than learning something, maybe just been inspired to do something interesting, either in this jam or beyond, and maybe not be too scared to try out computer vision and to do things with Python in a fun way. Okay, well, I hope you've enjoyed very much. And that is everything. Goodbye.